Next thing I want to talk about is depth of field. Depth of field is giving the scene depth in the render. So things that are close to the camera, for example, might be in focus, and things that are further away from the camera might be out of focus. The truth is what you have is something called a focal plane, and then you have the thickness of that focal plane. And you can move that focal plane throughout the scene. So maybe I want the body of the robot to be in shading. I want that to be in focus, but I want this hand to be out of focus and that hand to be out of focus. And it's simply telling Mentor or Maya, for instance, where to focus, and then it's telling it how wide that focal plane is. So those numbers can be sort of difficult to derive, but let me show you where you input these things. Underneath the camera attribute editor, if I go under depth of field settings, and I tell it that I want it to render the depth of field, you've got a couple of different things in here to consider. One of them is focus distance, the other is f-stop, and focus region scale. Focus distance is the point at which the camera is trying to focus. So the higher this number, the further away that distance is, the lower this number, the closer it is. F-stop is talking about how wide that field of focus is. The lower these numbers, the shallower that field is, and so the more things will appear out of focus, or the more dramatic the focus out of focusness is. And then the focus region scale, sometimes you have your scene set up so that things are very, very large, and maybe you can't get your depth of field to work properly. Everything always seems to be somewhat in focus, or maybe the scene scale is very, very small, and no matter what you do, everything seems to be out of focus. And what this focus region scale acts as a modifier so that you can make it consider bigger values or smaller values. So the most important thing to figure out here is how to get an easy setup for figuring out how far away from the camera an object is, and then inputting that number into your depth of field settings. So I'm just going to do a real simple custom camera setup here. Actually, let me make a new scene. I think it might be easier to see in a new scene. So inside of my new scene, I'm just going to create a new camera. I can do a camera plus a name. It doesn't really matter what kind of camera you're going to use. And then I'm going to use a measurement tool to give me a distance. So I'm going to, underneath shelves, I have my measurement tool right here, or you could go under create measurement tool distance. And I'm just going to draw this distance out from point A to point B, for example. And what I'm most concerned with is what this number right here is. So one of these nodes or locators needs to stay with the camera, and then one of them I can move throughout my scene wherever I want to focus. So the easiest way to get these two things to move together is just to simply constrain. So I'm going to use a point constraint node, and the constrainers work with the object that's constraining first and the object that's being constrained as second. So constrainer and then shift constrain. I'm going to go to constraint point, and it snaps the locator to the camera. And now, as I move the camera around, that locator will go with it, and my distance is always being adjusted, or this number is always being adjusted. So let's say that I have a real simple scene out here of a sphere and a cylinder and another sphere. And if I look through this camera, camera 1, I want to tell it to focus on, for example, this cylinder. So now I've got this node placed on this cylinder, I've got this number being output, and I want to tell the camera that this is the depth that it's focusing on. So I have to get this number to make sense to the camera. So the next thing I'm going to do is I'm going to use something called the connection editor. This is a very simple procedure. I'm trying to connect shape node to shape node, basically. So if I go into Windows, General Editors, or I'm sorry, Relationship Editors, so I'm going to go into Windows, General Editors, Connection Editor, and inside Connection Editor, I have my camera that I could load up here, and I have my distance. So I have to figure out who I'm trying to plug what into. I'm trying to output the distance from this node to the input of this camera node. So if I tell this distance to load, if I scrub through here, what I'm looking for is an attribute called distance. And there's two nodes on every object within Maya. You have a translation node and you have a shape node. Translation node is talking about general things like where is the object, where is the pivot location. And shape node is talking about things that are specific to that object. For example, if it was a shader, it would have shader information. If it's a camera, it has camera information. In this case, it's a measurement tool, and it has measurement information. And what I'm trying to get at is this distance. So by selecting this object, what I initially have selected is the translation node. If I want to step down to the shape node, I just hit the down arrow, and it loads me into the shape node. And if I so I select this object, hit the down arrow, and tell it to reload left, all of a sudden I have distance showing up. And I'm going to do the same thing with the camera. If I hit load right, and I haven't stepped down into the shape node, I don't see any place to plug this in. If I simply hit the down arrow and reload right, all of a sudden I can see focus distance. So right here, focus distance. I want to plug distance into focus distance. Once I do that, I can see on my camera that the focus distance is being controlled by the input value of this measurement node. And now, no matter where I move this guy, I'm going to get these focusings. So I'm going to open up my camera. I'm going to take a look at my depth of field, turn depth of field on. And as I grab onto this node, and I move it around, I'm going to tell this window not to auto load, so it'll just leave this guy up. As I grab onto this node and I move this around, I can see that my focus distance is constantly shifting. And because of that, I'm going to be able to easily tell the camera what to focus on. And another important thing here is that, number one, I'm not guessing. And number two, a lot of times some people will use an expression that relates the camera to always focus at its viewpoint. And I don't want to do that because maybe I want to look at something else in the scene and focus on something. I want to look at object A and I want to focus on object B and sort of do maybe a rack focus or something like that. So this gives you the ability to animate these things independently of each other. Which I find very useful. So that's the camera setup. You're connecting the distance attribute of this measurement node into the focus distance of your camera. So let's go back into my depth of field setup with my depth of field robot. And the depth of field within Mental Ray is going to be rendering as an in-camera effect, so it will show up inside of reflections and refractions and so forth. It's not a post-effect blur that's being applied to it. However, normally in a camera when you have depth of field blur, you get light blooming, which means that it'll push the light values of a hot surface hotter, and it doesn't really do that within Mental Ray. It will bloom the surface, but it will not adjust the gamma levels. So that's something you might have to do in a post application like After Effects or Shake, and sometimes that will mean that you want to output a Z-depth channel and do your blurring inside of that. But if you do want to do your blurring in scene, the depth of field within Mental Ray is very, very nice. But as all higher ordered levels of render operations are, it's quite expensive to render. So again, the most important thing you can do here is figure out how to troubleshoot what the render is doing and adjust those artifacts down. So I'm going to take a look at my View Camera Attribute Editor. Open this up and go down to depth of field, and I'm going to turn depth of field on. Right now we're set to focus on the finger of this robot, and my depth of field is set to, my focus distance is set to this guy, which I can see in my measurement node here, and then my f-stop is set to 5.6, which is a fairly low f-stop. Maybe I'll set this up to 25, and I'll kick a render off and see what happens. So I haven't done a render within this scene yet, so I'm just going to tell it to load presets, initial settings, and this will make sure that our settings are all set correctly. And then I can go to my render view, and it looks like our resolution is set up a little bit high. Nope, 725/47, that's okay. So let's render that out. And the first thing that you might have noticed down here in this window is that it said translation. And as it translates the scene, it builds the Mental Ray approximation or the Mental Ray equivalent to your Maya scene, and it generates the file for it. Here we come with our rendered scene. Now there's a little bit of focus distance. There's not that much. You can see that this hand back here is a little bit soft, and that objects closer to us are a lot sharper. We can see that we definitely have some aliasing artifacts. For example, contrast threshold would probably, by being lowered, it would probably solve some of these problems up here, and certainly it'll take care of some of the aliasing in this image. Let's take a look at this guy with no depth of field applied, just a nice clean render. So we can see that the surfaces are nicely tessellated. We shouldn't be having any problems with artifacting within here. There's a lot of little ridgy surfaces that could potentially cause problems, but with proper tessellation settings and proper anti-aliasing settings, which would be set to a 0 and a 2 and a 0.1 for all the contrast stuff, we should get some nice results. Now what I want to get to is this next image, which is the robot with depth of field. And in this image, this is rendered out as a 2K image. You can see that the depth of field has been very nicely dealt with. It's very, very smooth and washy. And the objects that are in focus are very, very sharp and in focus. Now, one thing I will tell you about this image is that it took a while to render. And the reason is these aliasing settings are very, very low. And that's one of the beauties of Mentor Ray. You have the ability to tune the quality of the render solution to a very, very high level. That comes at an expense, but the point is that you do have the ability to tune it to that fine level if you need to. So if I have a couple hours per frame, in this case, to resolve these beautiful depth of fields, then that's fine. And if I don't, I can use any level therein and just try and be satisfied with that quality. So most important thing again is rendering, is understanding what the artifacts are as we render this stuff out. So I'm going to be set to 720/547, and I'm going to turn my f-stop down to where it was, which was 5.6, and we'll render another one of these guys out. Again, translating the scene. And here we go. There's going to be a lot more depth of field now. One thing you will notice is that the aliasing is quite predominant within the scene. There's a lot of aliasing going on, and that's because depth of field is going to require a lot more samples to be taken within this scene than what we currently have. So by adjusting my sample settings, I can alleviate this graininess and I can tune this back in. So that's what we're going to do. I'm going to pick a small portion of this render to tune up, and we'll adjust it down so it's nice and smooth. So I'm going to select this portion right here, and I'm going to go into my render settings, and under the number of samples, I'm going to set my minimum number of samples to 0 and my maximum number of samples to 2. And the reason I'm going to do that is to get us to our initial production settings, and I'm going to go to my filter settings and tell it to go to Mitchell. 4x4 is fine, and we'll render this portion out. So you can see that by setting this to 2x2, this render region looks a lot nicer, but it's still grainy. So there's some adjustments I can still make. I'm going to start moving down my contrast threshold, 0.05, at 0.05 all the way through, and try that again. So it looks a lot nicer. It's still got a little bit of graininess, so I can keep moving this down. And just for the sake of showing you that it can be adjusted to the finest level possible, I'll go on ahead and adjust this down one more time. But this is set to a 0.05, and we're getting these kind of results, and that looks pretty nice. And again, this scene is set up with pretty default shaders. This is a chrome shader and just an environment that it's reflecting off of. And in a lot of the scenes that I'll be showing you, I'm either using very simple shaders or I'm using gray shaders. And the reason I'm doing that is that textures hide a lot of artifacts, which is a good thing in production, but if you're trying to figure out how to solve those artifacts, it's not going to help you if I show very complicated textures that hide all these artifacting. So by using either something like a chrome or a gray shade, it allows you to see an awful lot of the problems that might be present within the shader. Or within the surface, and it's not hiding it with a shader. Now, having said that, it's also important to note that if this was a production level setting, or a production level model, and it was textured as such, a lot of these depth of field settings may not be a problem. The fact that there's a little bit of graininess in here may not bother us. So it's important to tune these things up on your actual production level or production ready renders, because sometimes adjusting these samples down to an extremely fine level on a very simple gray shaded texture and then applying your high resolution textures and rendering it out, you might be achieving a level of refinement that's not necessary because you can't notice it within that texture. So it's important to always tune the scene based on your final resulting surfaces with their real textures. But for the sake of displacing these artifacts and really teaching you how to tune them up, I'm choosing to use these simple shaders. So again, I'm going to go on ahead and tune this down one more time. And this is going to be a very, very low setting, and it should look pretty nice. Now, having said this also, speaking of making sure you're adjusting the appropriate things, right now I'm adjusting this to 720 by 547, which is a fairly low resolution. It's appropriate for television or broadcast, but not for HD and certainly not for film. And if you were going to be doing a film resolution render, you would want to make sure that you had turned your resolution up to that 2K setting, for example, 2048, 1556, and then done this render again and make sure that some of those sample problems don't become obvious at that higher resolution, because the higher the resolution, the more those sample problems are going to become obvious in this case, and then sometimes it'll resolve itself because it has a higher or a larger amount of screen real estate to sample across, and it'll smooth out those sample regions. So again, here it's tessellating the surface, and now it's going to go on ahead and shade this. So there's my render with the render setting set down to 0.001. Now, just for the sake of being nitpicky, I can certainly see that there is still some graininess inside of there, and I've pretty much set this contrast as low as I can go, and yet I still have graininess. So the next step would be to lower our maximum samples to, up our maximum samples to 3, and I'm going to return this back to a more reasonable setting like 0.01 and see what happens. Now, in a situation like this where you are forced to increase the maximum samples, it's going to make this render exponentially more expensive. Because forcing it to, or allowing mental rate to get up into the maximum sample levels of 3 is going to allow it to super sample shaded pixels up to 3 times what it normally would. And it's going to make the render a lot more expensive. So you always want to try and adjust the quality of the render in terms of the graininess or the texture definition by first adjusting down the contrast levels and see if you can pull some of that detail in tighter. And if you can't get it any tighter, as in this case where I had it down to 0.001 and we still have graininess, then it might be important for you to take your maximum sample levels and turn it up a little bit and try this render again. So here we are at 0.01 and maximum sample levels of 3. Okay, so you can see the finish shading here. It looks very, very smooth now. All these artifacts have really been gotten rid of, and it's pretty nice. And it came at an expense. If we look at the output window, this one little small section took 2.48 minutes to render. So it's expensive, it looks very nice, and I think that's the most important thing, is that you have the ability to resolve these images to an extremely high level if you want, and if you don't want, you can tune backwards and get rid of it. So again, I'll just show you the final rendered image so you can see that things can be very, very smooth, and everything looks very nice in this image. And you know, depth, like I said earlier, Mental Ray is a very stable renderer. It doesn't have tons of artifacting within the images until you get into specific kinds of things. But even when it does artifact, it tends to be fairly stable. You don't get a lot of popping surfaces or swimming things once you've tuned stuff up. It's pretty stable.